Share screen, share slideshow. Okay, can everybody see the screen?
Yes.
Perfect.
Yes.
Okay, so bon dia.
Good morning.
Yeah.
Bom dia.
Yeah.
Later on, I'll tell you about the fact that I can make pretty good feijoada, but that's a different story. So I want to cover what kind of motivated this, what our mission is, this technology we've developed called an edge cloud, which is an infrastructure to allow applications, and I'll give you an idea of what those applications could be, are, and could be, and then quickly talk about what the next steps could be if you guys are interested in being part of this. So just by way of introduction, and if you listen to the podcast, you probably already heard this. So I don't know anything about medicine. So I spent my entire career in IT and software in particular. I ran the cloud computing business at Oracle. I've been teaching at Stanford actually since 1981, originally core curriculum. And then when I came back, I started this class on cloud computing, which is how I met Dr. Anthony Chang, who at that time was head of pediatric cardiology at Children's Hospital in Orange County. And Anthony has been a part of this project since the very beginning. So what Anthony taught me about, I'll say, your world was that, people are still, I was amazed by this, people are still using CD-ROMs to pass data around to share MRI images. There was actually a little boy 2 years ago in Southern California who went undiagnosed with brain cancer because they couldn't share data between 2 pediatric hospitals and 1 clinic. So I'm like amazed by this because from a technology perspective, this is a simple problem to solve. We just talked a little bit about AI. The AI, particularly deep learning, all the work in this area is heavily influenced by the amount of data. So if you do not have enough data, you cannot build these algorithms. And this is actually a conference that got run at Texas Children's, you see, in 2020, and they're talking about not enough data, which leads to the fact that, and this is Stanford's AI and medicine project, that these algorithms are brittle because they are trained on small data sets. So, and this is particularly acute problem in children's medicine because no one children's hospital has enough data to build any of these algorithms. So this kind of got me thinking about, well, what are the technical challenges to cracking through this problem from the very simple, like collaboration, to the more complex, meaning building AI algorithms. And it is interesting to note that the EU just released a report on AI medicine, and they made one technical recommendation, which is the need to enable access, use, and exchange of healthcare data. So we focused on that part of the problem, and let me first say, we don't think the data's in the EMR or the EHR. I mean, yeah, I know there's doctor notes there, or I call it a billing system, but that's not where the real data is. The real data is sitting in the machines, the ultrasound, the gene sequencer, the blood analyzer, the CT scanner, the X-ray machines. We estimate there are about 1 million healthcare machines in all 500 children's hospitals in the world. It may be a larger number than that, but it's at least 1 million healthcare machines. That is where the data is. The second thing we are trying to tell the community is stop thinking about aggregating the data in big central repositories. There's actually projects in the US at NIH to try to do this in adult medicine. There are 2 fundamental problems with central repositories. One is technical, meaning once you build data that you are thinking about organizing, you organize a schema. That schema ultimately can be used for the first application, but the second one's very difficult for it to happen. And this is years of experience that we've had in enterprise software. The second problem with these central repositories is they fly in the face of fundamental privacy questions. So one of our team members is a former student. She has 15 years of experience in privacy law. And one of the central ideas in privacy is that you have to have purpose limitation. And when you say, I'm just going to put a bunch of data somewhere, and you got, well, what are you going to do with it? And you cannot answer that. That's not purpose limitation. So we think central repositories are kind of a dumb idea. So we think there needs to be a new infrastructure where, number one, you can standardize the data from any healthcare machine around the world. I will show you how you could do that. Two, enable application-specific data access, not a repository. Three, enable learning to occur with privacy constraints continuously. And finally, build an infrastructure which actually takes these applications and deploys it to the point of care. Frankly, whether that's in a hospital or in a clinic or in a home, right? Okay, so we set ourselves this Moonshot mission you heard about, that we want to enable a new generation of applications based on access to data from all million healthcare machines in all 500 children's hospitals in the world. I'll just stop for 1 second, and any questions?
And no. The only thing that I'm thinking about, you get the data from all the machines in those hospitals.
Mm-hmm.
And you take this data and you work with the data, or you explain better after. How do you work with the data?
Okay, I will explain that, and there's two parts to it. One is, how do you get to the data, and then what do you do with the data? Okay, so I will show you that. So
another question.
Yeah.
You have the data from ultrasound, X-ray, MRI, CT, and so on.
Yeah,
Nuclear
we
medicine,
started-
blah, 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 blah.
Yeah, just to say it, we started with ultrasound. We focused on ultrasound because obviously we talked to a lot of people with pediatric cardiology. So
Because ultrasound is a challenge, it's a big challenge especially for IA. Well, with CT, with MRIs, I think it looks like it's easier than ultrasound for work with IA. Or I'm wrong? Do you think I'm wrong? Do you understand what I'm trying to say?
yeah, so there are many reasons we started with ultrasound. One is it's more difficult.
Yeah,
So
yeah.
we knew that if we could do ultrasound, everything else is actually easy.
Yeah, I agree with you.
Right? So we developed this technology, we call it Edge Cloud. So if you took my class on the very first day, I explained Amazon, Google Cloud, Microsoft as they buy a bunch of computers, they manage them, they deliver them in an OpEx model per minute, per day, whatever. And they put those computers in about 10 data centers in the world, which at this point in time, I think does not include Brazil, but in 10 data centers in the world. So what are we doing? We're fundamentally doing the same thing. We're acquiring a bunch of computers, what we call edge servers. We're going to manage them. We deliver them in an OpEx model. We've just designed the capability to put them in 10,000 data centers, meaning inside all 500 children's hospitals in this use case. So let me zoom in and talk about what this looks like in a little more detail. So the first thing that we do is we establish what we refer to as an edge zone, which is in essence establishing a secure network perimeter in which these servers can live. There's a detail I can go through with you about how the edge network does this, but a zone is in essence a unit where everything is managed identically. Just to be clear, it is not necessarily one building. We're actually at Bambino Gesù, which is in Rome. There are 5 buildings in the Vatican. There's one edge zone, okay? So the edge zones are where the compute and storage live. We have built a very specific kind of application which replicates the data in the machine. So we'll just talk about ultrasounds. So there's a Philips digital twin running on the edge server. There is a one-to-one relationship between the edge server and the machine. So if I showed you a photo, the edge server is about the size of your hand, and we actually paste it to the bottom of that tray on the ultrasound. So there's a one-to-one relationship, and that digital twin is a piece of software which talks to the ultrasound and replicates the data. So when I say replicates the data, what do I mean? I mean replicates the static data, what's the serial number of the machine, replicates the environmental data, where's the machine located, replicates the dynamic data, what's the last error log that the machine threw out, and finally what we call the gnomic data. So it replicates the data, the actual echo in the case of the ultrasound, it replicates that as well. It puts that into what we call edge data services, which is our security mechanism to allow for controlled access to that data. So the way we've made this is, Antonio, you own the ultrasound on the 3rd floor of the hospital. You get to decide if any data is shared, right? You could say, I don't want to share any dynamic data. I don't want to share any environmental data. But if you say, yes, I'm willing to share environmental and gnomic data, then the next question is, with which application? So you could say, well, application A that Leonardo wrote, I trust him, I'm willing to share with him, but I'm not willing to share the data with, the TIM application. So application by application, that's why I said application specific sharing of data. And I will show you examples of applications, but this is how we acquire the data and how we make the data universal. So the ultrasound running in Italy and the ultrasound running in Sao Paulo and the ultrasound running in California, the data is all the same inside the edge servers. We then allow for, we have something called Studio for people to build applications. So these could be, and I will show you an example, an application for a clinical or a biomedical engineer, applications for radiology, applications for cardiology, applications for neonatology, okay? So these are all built with what we call Bevel Cloud Studio, which, as you guys get interested in this, we could give you access to allow you to build applications as well. So this is the fundamental infrastructure that we built, which is composed of edge zones located in our objective is all 500 children's hospitals in the world. We enable a digital twin to replicate the data, make that available to edge cloud applications, which could both be clinical as well as clinical engineering applications. So let me just stop there and answer any questions, and then I will show you 3 example applications.
Okay, yes. Yes, Fernanda?
Yeah, I have a question. When you talk about data, you mean the images that we have in exams, or you mean both images and reports?
Everything that the machine knows, we know. So if in the case of the Philips ultrasound, just pragmatically, what ends up happening is when the stenographer or the clinician hits send to send it to the PACS system, we get the identical image. So every day, all data that a machine has, we have.
And
Okay.
Timothy, one other, Fernanda, could I make a question? Do you have any Any
No,
more
go
questions?
ahead, please.
For example, if I finish one examination, of course, and then I finish in the ultrasound, and my data went to you in the, how do you call Bovel cloud, to the cloud, and I can share this exam if I have doubt, or you get this data to work with this data to make one IA. Do it make sense, my question?
Yeah, so, and maybe when I show you applications, it'll help more. What we're doing, what Bevel Cloud does is when you do the exam and you are ready to send it to the PAC system, we get a copy and it is on the machine, it is on the edge server in Sao Paulo, okay?
Okay.
Now,
Okay.
at that point, if access has been granted to Luciano's application, then, okay, Luciano's application wants to analyze it locally, that can be done. If Luciano's application wants to send it to London, you could do that. All the above are possible depending on what the application wants to do. Obviously in a secure way.
Of course.
So I think it's useful. Let me show you a couple of applications that'll help you think about what we're trying to do. So I'm going to show you 3 applications. The first is an application by a company named Teleray. So this is a company that actually built the software to burn CD-ROMs. So they've joined the modern world. This is what we call center cloud application. So the way it works is, okay, there's the Philips machine in Sao Paulo connected to the edge server. And the Teleray application is running on the edge server. Now, back to you finish with the exam, you send it to the PAC system. The Teleray application will take that image and bring it to Teleray's center cloud, which happens to be running at Azure, which then at that point, based on their security mechanisms, you could share with a doctor in Orange County or a doctor in Rio or whatever. So completely shareable, basically within security constraints. So we actually are getting ready to demonstrate how every children's hospital in the world that wanted to could actually go and look at any image from anybody in the world. So, but obviously, yeah.
And then if I, for example, I have one examination that I finished, it would be like really would be like a net of departments of radiology, for example. If I have one examination that I just finished and I want that one staff member of Texas to take a look, that's my friend, I can be in touch with him and he can access my exam. Okay, I can, and then he immediately he can send me a message to say what he's think about this the exam and so on.
Exactly. Because he'll be looking at the same image you're looking at.
It'll be like a net.
Yeah, it's in essence a replacement for the CD-ROM, right? A modern way of doing this.
Yeah.
So this is simple collaboration.
Yeah.
As I said, it could happen regionally. You could do this across Brazil. We could do this around the world, right? There's a lot of different combinations of who and how to share. So, Leonardo raised his hand.
Hey, Timothy, let me make a question. Might help everyone in the meeting. About the artificial intelligence.
Yeah.
What it can get the information back from the exam that you make in our machine, and there's a way to get like some diagnosis that I say that this exam shows something else, and I can get that in a easier, faster, in a proper way.
Okay, so I will show you an AI application as the third application. Okay, so this is an application that enables, we'll call it collaboration between clinicians. This is an application to help the clinical engineer. I don't know if you call them that in Brazil, or a biomedical engineer. It's the person who's responsible for the ultrasound, the maintenance of the ultrasound, the service of the ultrasound. So remember, I said, we get the serial number, we get the location, we get the error codes, we get the echo. So now with the UNITSA application, which is another application running on the edge server, if you give it permission to have access to this data, then the UNITSA application can now enable your clinical engineer to see, what was the error code that came out of the machine, enable a Philips engineer to see the same thing, to be able to locate the machine, to know how much the machine is being utilized, to know what was the last security patch made available for that machine. So this is an application that is there not for the clinician, but for the clinical engineer that uses other data, right, that's available from the machine. Okay, let me give you the last one. This is an example of an AI application to Leonardo's question. So this is an application that that the folks at Stanford are building. It's called EchoNet Peds. It is based on doing a AI-based analysis of the ultrasounds to deliver back information like, I think it's injection fraction. Obviously, I don't know. I can give you more data on this, but it is an AI application that was built with a small data set of, as you can see, 4,400 echoes, right, that they built locally at Stanford. The next step with this application is we want to deploy it at every one of what we are calling the Vanguard hospitals. So the application will be deployed in Rome, hopefully in Sao Paulo, right, in Connecticut, in California, the same application. And we're going to test, or Stanford's going to test the accuracy of that application in its diagnostics. And then the last part is, and this is very advanced technology referred to as federated learning. We want to enable federated learning to improve the accuracy of this algorithm. So quite briefly, federated learning is a way of training an AI algorithm where you use local compute. So the training will actually occur on the third floor on that ultrasound edge server. So no data ever leaves the building, which both preserves privacy as well as obviously preserves the network bandwidth. Just to make a point of it, it's the very same technology that is running Siri in your Apple phone. So Siri is trying to improve the accuracy of understanding your speech. They do not take the voice print and ship it to the Apple cloud. There's actually learning occurring on the phone itself. So this is the same type of technology now being applied to medical imaging, where we're going to learn locally, which, as I said, both preserves privacy and network bandwidth. So let me end there and answer any questions about applications, about the infrastructure, etc. So
one question, Timothy, in AI, for example, for ultrasound, I think that you need to have one standard way to do the exam, because you need to have one standard way to do the examination that you can replicate with all center to get the same data. Or do you understand what I'm trying to say?
Yeah, I wondered about this too, but I think they feel, and it'll be useful, there are multiple AI applications we're working with. They feel that by aggregation of a large enough data set, they can deal with that problem.
Okay, wonderful.
Right. And to be able to come up with pretty good, reasonable accuracies in this. So Yeah, it's a good question. I understand what you're asking. Yeah.
And what about like, we send the image and what about the diagnosis? So I'm gonna do an ultrasound and I found a kidney mass in a child. So you get all these images from this exam, but how you're gonna know what exactly I have the impression, what I put in my report, because they are different systems, right? The ultrasound machine and the PACS that we use to make our reports.
Yeah. So, go on.
In another question, based in this idea of Fernanda, for example, I'm on call and I have an ultrasound that I found a mess, a kidney mess. And could we have one AI that for at night that this aspect of this mass in the kidney, this looks like one specific tumor. Do you think you can work in it also?
Yeah, so let me try to answer both questions. So this is just so I'm clear, this is an application question. So the application has access, I'll use your tumor example, has access to the data. If it has been well trained and it's accurate, it's going to be able to go, hey, Antonio, this looks like a tumor. Now, how does it tell you that? Well, the application could tell you that by sending you a text message. It could tell you that by sending you an email. It could tell you that by communicating with the PACS system and showing an alert. The application makes that decision in how it wants to communicate with you. It's diagnostic. Does that answer your question for that? Yeah.
Yeah, but how are you gonna validate it? So you're gonna like trust in the, how are you gonna validate that all the informations that are first sending are,
Yeah, so the developer of the AI application has to go through, which is one of the things we're trying to help people, testing of this application, and for the first time on a global basis. So the first step is, well, how accurate is the EchoNet Peds, we'll just use that as the example, application itself? And how does it improve the accuracy? We're talking about how it could do that. Before you get to the question which you're asking, which is, am I ready to use this in clinical practice, right?
right?
So what we're trying to do is accelerate the availability of data to being able to build these applications, accelerate the ability to take smart, just to say it, there are research groups around the world. There's a research group in Norway who's been working on, I don't know what myocardial infractions are, but they've been working in this area. We can now take their knowledge, encapsulate in software, put it into the edge cloud, and now it's available all the way around the world. So we think we can speed up the pace of innovation by virtue of this infrastructure, where today everybody's kind of stuck behind trying to get data into some central repository or standardization or all these other issues. So all your questions are great. They really become application questions. And we are adding more and more applications to our conversations, frankly, in neonatology, in neurology, in cardiology, in oncology. And I would encourage, I'm guessing even today, there are research groups in Brazil who are working in these areas, developing AI technologies that today are sitting, I call it, they're sitting on a research paper. We want to put them on the edge.
I think in application, we have an amazing opportunity in pediatrics, in imaging in pediatrics, because in AI, we are, how do I say, in pediatric radiology, we are the adult radiology is much more advanced than pediatric radiology.
Yes.
And one thing that, one reason that I think is because in pediatric radiology, we use a lot of ultrasound and a lot of X-ray in radiology. And of course, they are working much more with CT, MRI, even mammography, and so on. And if you have the opportunity to work more with ultrasound, that's very difficult, be wonderful. And another thing is that if you can use those data to help people that is away, like even in Brazil or Africa and so on, and they needed to help in one diagnosis, if they are on call, like at night and so on, we can help them. I'm not sure if it's possible to work in this kind of application.
Antonio, just to keep going with what you're saying, one of the things we've done is we've twinned an edge server to a Lumified portable ultrasound from Philips.
Okay.
So now all of a sudden, an algorithm to, tumor detection, whatever, can now be deployed all the way out to a handheld portable ultrasound, which is, yeah.
No, I'm sorry. No, I'm sorry. No, I'm sorry. It's because the things are coming in the brain. I'm sorry. No, because, man, if it's possible in the future, for example, if the equipment, the machine you finish one exam, and when you finish this exam based on the data and the aspect of the image, I'm not sure, maybe the equipment can make suggest about the diagnosis.
That's exactly how we, the software, in essence, connected to the machine, can make a recommendation that, you really ought to go talk to Antonio. I mean, as an example, right?
Yeah.
I mean, there's so many different possibilities.
It's a wonderful thing that we can do, man, with the data and with the equipment and with softwares.
Yes, yeah. So we think it's really we're freeing up the software developers of the future to innovate in amazing ways that were never possible before by building out this infrastructure, what we call this edge cloud. So yeah, I think you understand what we're trying to do.
Yeah, and I think for ultrasound it's even more tricky because you don't have like a padronization, you don't have the same image every time because it's operator dependent. And if you need more data than for the Excel methods like MRI, CT, that you have almost always the same image plane, the same quality. Right. Ultrasound is completely out of control.
Well, it's, like I said, one of the reasons we started with ultrasound, in fact, if we provision a zone with you guys, it will be with an ultrasound machine because that's where we started. It's because we started in cardiology. So, and Dr. Chang's a cardiologist. Most of who we are talking today are the big cardiology, the echo labs in all the big hospitals.
Dr. Chang, what's the first name of Dr. Chang?
Anthony.
Okay.
Anthony Chang, yeah.
He's a radiologist.
He is a cardiologist.
Cardiologist, okay.
Yeah, he just published a book on AI in medicine. I'll send you a link.
Oh, wonderful.
Yeah.
At the TCH meeting of AI, he talked. He did a talk.
I'm not surprised. Anthony knows lots of people in the world. So maybe I've got you for one more minute. Let me tell you what the next step would look like. Is that, or are there other questions?
No,
thanks.
Okay, so so the next step is zone provisioning at your hospital. So what does that look like? So this is, I go back to, we are creating a secure network perimeter. It's a logical concept. So I'm gonna, the network engineers is usually who we end up talking with. So we tell them, because we are living in your network. So they get worried about this, and I understand why. So we architected, almost all of our engineering work has been in security and privacy. So we say, take our edge servers, use a VLAN. We will ship you an edge server. You guys will tell us which Philips ultrasound to twin it with. We will connect that edge server on the VLAN by enabling ACLs between the edge server and the machine itself, the actual ultrasound. This is a process we refer to as twinning. We will ask them to enable what we call port 443, which is standardized port for being able to exit your network. And so this goes through a secure VPN through what is referred to as a whitelist. So this is where we have to talk to your network engineers and communicate all of this so that they set up the ability to do this, which is a fairly standard approach for secure network protection. And what we will do on launch day is we will pick an ultrasound on the 3rd floor, connect it to the edge server. We say, or twin the edge server. Then we say, let's go image Antonio or image Jello. Then that image will actually be transmitted. We're going to use the telearray application to send that image all the way out to the telearray center cloud, where now, to your comment, Antonio, your friends at Texas Children's, if they were given permission, could actually see that image. So we want to test, this is an end-to-end test on launch day of the entire infrastructure. And then the last thing we're saying to everybody is, we want you to run the edge server continuously using it's a clinical application, which will let you start to see, utilization, online access to the Philips error logs, but not have any access to the nomic data. So that is, in essence, launch day, what the activities leading up to launch day, and what we want to have happen on that day and on the subsequently, which is letting it operate continuously. So any questions about this step?
No, I don't think so.
Okay. So I had the last few slides. We think we developed the infrastructure that could enable a massive transformation in children's healthcare around the world. It's a moonshot mission to do this. I deliberately, in fact, I have to give Leonardo credit. We want to run in all 6 continents by the end of this year. We are already in Europe and North America, and working in Africa. In fact, the meeting I had was with Gertrude's Children's in Kenya, and I very much wanted to add Brazil and our 4th continent. So we're inviting you to be one of the vanguard hospitals, and would like to know if you would like to be a part of the mission. I hope my translation software worked well.
Yes, it's wonderful. Você vai se juntar a nós nessa missão. We will be with you in this mission.
All right.
Wonderful. And Timothy, we would like to be a partner and to be with you in this mission, but we will need to discuss about the next steps and how we can work in it. The person that you need to join with us, the engineer,
Yes.
and everything that you need to bring with us to be in touch, to be what you need from us about the dates, about the softwares and so on, that will be together and connect together.
Yeah, I think what we should do is a meeting with network engineering in IT. Your security people are probably going to want to talk to us, so please bring them. If there are people with privacy concerns, bring them as well. The clinical engineer, or if you guys call it a biomedical engineer, because somebody will need to configure the packs, configure the ultrasound itself, which at least what our experience has been, the clinical engineer. So the clinical engineer, and then, the clinician. Most of our early work, as I said, is in cardiology. So we like to have, if there's folks running the echo lab, because many of the things we're starting to talk about are echo lab specific, but anybody on the clinical side. So that's kind of the.
Okay. And of course, you have one university of machines that will be frames different, like Philips, like another companies. Do you think it's no problem?
We don't think right now, pretty much every imaging machine from any vendor, we think we can build a digital twin.
Okay.
We've done it for Philips, and it works for both the Lumify, the Epic 7, etc. So we think it'll work for it. I mean, we haven't done it, to be honest, but we haven't done it yet. But we don't see any big deal with doing it.
Okay. Okay, I will be in touch. Thank you very much. But Fernanda Brao, who will be probably more frequently than me with everybody. I'd like to be in every event, especially with you and with your wonderful, beautiful cat. And we are excited. If we believe in it, we need to push it. AI and innovation in your hospital, we need to work in it. It's amazing, very good opportunities.
Well, I appreciate your enthusiasm, Antonio, your wisdom. There are not every leader of a children's hospital thinks this way, so I appreciate it.
Thank you.
Timothy, can I make the last question?
Okay.
Do you think that is going to be a amount of money that they have to invest to make this partnership? Do you know?
Yeah, so for the first group of hospitals, we are calling them Vanguard hospitals, zone provisioning, twinning an ultrasound, bringing this whole thing up. We are covering all the cost of doing that. So there's no cost on your side. I mean, ultimately, when you say, oh, I want to use this application, the UMNITS application, obviously at that point it becomes a commercial thing. But this step, no, we're covering all the costs.
Thanks so much. And other question, do AGCM has to know who is reading or has access to his image from other hospitals or not? Who's accessing their image, their exams? Do they get some reports telling who is examining or checking that or not?
No, what we are going to do is we will demonstrate the application Teleray to do image sharing. And then if you guys are interested in going further with it, then there's a lot of detail about that application and what it can do. Maybe, inside Brazil, across, but a lot of different conversations there, obviously. But we want to be able to demonstrate so that everybody can see what the possibility is here. How about that?
Okay.
So,
Dr. Timothy, it will certainly be a breakthrough. Thank you. Wonderful. Hi.
Well, Marla, thank you for your time. Yeah, so I'd say, I think you have my email address. So just, if Fernanda, you're taking lead on this for next steps, then just send me an email and we can start the scheduling process to kind of, go the next level of detail with all the appropriate people to provision the zone.
We're going to identify everyone that needs to be involved, and then I'll write to you and we get it.
Okay.
Okay. Thank you so much. Thank you very much.
Thank
Thank
you.
you. Thank you.
Bye.
Nice to meet you.
Good day.
Nice to
Bye-bye.
meet you.
Thank you,
Bye-bye.
Timothy.
Bye-bye.
Thank you.
Bye-bye.
Bye.